Welcome back, mathematicians. Today is our third and final day of equations of lines, and this is our third format that we would need to talk about, which is called standard form of a line, and it's written as ax plus by equals c. So x and y are together on one side, and so we're going to do 6 quick examples together. So for this method, I think the visual kind of speaks for itself. So what we're going to do is we never keep equations in this format. We end up rewriting them into slope-intercept form. Okay, so one way you could handle this is just type this entire equation into Desmos. So I'll type literally in x minus 4y equals 40. You'll notice that you can identify that y-intercept beautifully. So that y-intercept is at negative 10. We can plot that point. And now I need to find a second point to help me find the slope, guys. To do this, you need to click on your line and hold your mouse so you can actually see the points where you can create them. Now notice I actually just went past one at 4. I should be at negative 9 is what I just saw. So 4 comma negative 9 is also a point on my graph. And so now that will help us identify our slope. So we already know half our equation, guys. This is down 10 for our y-intercept. But we can also get our rise over run, our slope, from these 2 points. So how much did we rise? Well, we only went up 1. And then we ran 1, 2, 3. And to make it to that point, we literally had to go over 4. So up 1, run 4. And you, my dears, have now changed that equation from standard form into slope-intercept form. So we can do that again with all of these other equations. So let's do that quickly. So when you type in number 2 into Desmos, you notice that we had a y-intercept here at negative 2. And I also went up my line and found a second point there at 1 comma 5. So we're going to use those 2 things to help me find the y-intercept. You notice was at down 2 at the end, and now we need to figure out the slope. So the slope, I rose 1, 2, 3, 4, 5, 6, 7. So we rose 7 and we ran over 1. So you can write that as 7 over 1x minus 2, or you could just leave it as 7x minus 2, guys. Either one's acceptable. All right, let's do the third. So question number 3, if we put that into Desmos, you notice that your y-intercept is at negative 4. And you also find a second point as you go up to 4 comma 1 is your next really nice coordinate or point. So we're going to use that to help us. So your y-intercept was down 4, and now we need to find the slope. And I counted up 5 and run to the right 4. So 5 over 4 is our slope. Now you're probably wondering, Miss Weldy, is there another way that I could do this? Because these slopes are looking kind of interesting. You could probably see that it's the number in front of x divided by the number in front of y. That's the slope. And there's a little something funky going on there to get that y-intercept. So there is, in fact, another way to do this, guys. You can use algebra. So to use the algebra way of doing these or solving these, guys, I have to get y by itself on the left side. So instead of adding by x, I'm going to subtract each side by x, which gets rid of that x altogether on the left. Which means now I got to do one more step here. Instead of multiplying y by negative 4, I'm going to divide every piece I have by negative 4. Now I know that seems a little scary. 40 divided by negative 4 is negative 10. Ting, 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 ting. And a negative 1 divided by negative 4 is going to leave us with a positive 1 over 4x. Ooh, that should look pretty familiar, ladies and gentlemen. That is what we found when we used our graph. Our slope was rise 1, run 4, and our y-intercept was at negative 10. Huh, you mean I could actually do that and find it out algebraically. So let's do another one here. So instead of adding by 7x, we're going to subtract by 7x on the other side. We'll get rid of that 7x on the left side so you don't freak out. Technically, this y has a negative 1 in front of it, so we're going to divide by that negative 1 for every single piece. Once I take 2 divided by negative 1, I get negative 2. Negative 7x divided by negative 1 is a negative divided by a negative is a positive. And guys, this looks like exactly what we got when we graphed it. We got 7 over 1x minus 2. Oh my goodness. So for number 3, instead of adding by 5x, we're going to subtract by 5x. And instead of multiplying by negative 4, we're going to divide by negative 4, undoing those operations. So 16 divided by negative 4 is negative 4. A negative 5 divided by a negative 4 becomes a positive. And we end up getting the same slope and the y-intercept we found using our graph. So guys, you can actually pick your poison here. You can either solve it by moving the x over by the opposite operation and dividing by the number in front of y to find that slope and that y-intercept. But be careful, you have to do the switcheroo there. The number in front of x is your slope, and the number that you get is the y-intercept. So we could do that again to help us out here. So for number 4 through 6, we're just going to go straight up through the algebra. But feel free, guys, you can do this using just Desmos. So for number 4, we need to subtract our 6x over, and we're going to divide by 4 to everything. 16 divided by 4 is 4. Now, negative 6 divided by 4 does not divide nicely, so you can keep it like that, or we can reduce that to a negative 3 over 2, whatever you decide. And that 4 is positive, so we're going to keep that as a plus 4 at the end for our y-intercept. So remember, guys, you're moving the x, so not adding by 7x, but subtracting by 7x. Not multiplying by negative 7, but dividing by negative 7. So we end up getting 1 over 1x, or you could just put 1x, guys. And we also have a y-intercept here of not positive, but negative 1, so down 1. All right, over here, we're going to subtract 2x to finish it up. Divide by 3 from all pieces to get y by itself. And negative 18 divided by 3 is negative 6, which is our y-intercept. And we end up getting a slope of negative 2 divided by 3 because that does not turn out to be nice. So hopefully this was a great little way to change your standard form into slope-intercept. Please choose, guys. Either use the Desmos route or use your algebra route. Be careful.